Welcome to the viewers. We discuss today the solutions of the heat conduction in solids and its applications of partial differential equations and the heat conduction problem in an infinite rod. At first, let us consider with the problem, and we use it the Fourier transform method. Now let us take the solution. Solve the following heat conduction problem. As follows. Del V del T is equal to lambda del 2V del x2 for x belongs to minus infinity to infinity. Initial condition, that means we are using these conditions. U x0, that's a Vx0, is equal to Gx for x belonging to minus infinity to infinity, and Vxt del V del x, that is Vx of xt, that tends to 0 as mod x tends to infinity. But here we have to solve this problem. So at first, let us denote the Fourier transform. The Fourier transform, or shortly write ft of Vxt with respect to x by V bar kt, and since f of del V del t, that will be by definition 1 by root over 2 pi minus infinity to infinity del V del t e to the power I kx dx, and since partial derivative, that makes also total derivative 1 by root over of 2 pi minus infinity to infinity V of xt e to the power I kx, and it will be dx, and it is by definitions of Fourier transform V bar, so it will be dv by dt. Now if we take Fourier transform of del 2V del x2, and it's clear that will be by use of the properties of Fourier transform, derivative of the Fourier transform, take ik whole square and that V bar, so it will be minus k square V bar. It is by definitions, and now it is take by definition, that is f of f dash x, that will be minus of ik, it will be f bar k, if f bar k be the Fourier transform, or f of fx, we can write it in this way. So it will be right in this manner. Therefore, from the primary conditions of 1 using, therefore from 1 del V del t equals to lambda del 2V del x2, taking ft from both sides, Fourier transform that is dv bar dt, that will be minus lambda k square v bar. We have to integrate it, that is ln v bar equals to minus lambda k square t plus ln a. Ln is the integration constant. Ln actually v bar, not a vector notation, it is simply v bar. V bar by a, that will be minus lambda k square t, that is v bar equals to a into e to the power minus lambda k square t. Now here v bar of it will be k t, that will be a e to the power minus lambda k square t. Therefore v bar of, if we put t equals to 0, k 0, then it will be a into e to the power 0, that is a. So we find a is equal to v bar of k 0, and from the conditions we have find in the second condition, using we rewrite the second condition, v of x0 is equal to g of x. Therefore v bar of k0, that will be g bar of k. It's simple. Therefore u bar of kt, that will be have some make some constants, that is a, that will be v bar of k0, v bar of k0 into e to the power minus lambda k square t, that will be g bar of k e to the power minus lambda k square t. Now to get back v bar of xt, to get back vxt, we take Fourier inversion formula. Let Fourier inversion of hx, that will be e to the power lambda k square t, that will be h bar k. Therefore hx, that will be 1 by root over of 2 pi minus infinity to infinity e to the power minus lambda k square t into e to the power minus ikx dk by Fourier inversion formula. So here we have to solve minus infinity to infinity to the power minus lambda t k square plus I k x by lambda t dk 1 by root over of 2 pi minus infinity to infinity to the power minus lambda t k square plus 2 I k x by 2 lambda t plus x square by 4 lambda square t square minus x square by 4 lambda t dk. is equal to e to the power minus x square by 4 lambda t 1 by root over 2 pi minus infinity to infinity to the power minus lambda t. It will be taking it minus, so k square plus 2 I into 2k into ix by 2 lambda t plus I square x square, that will be minus 1, 2 lambda t 4 lambda square t square dk e to the power minus x square by 4 lambda t 1 by root over 2 pi minus infinity to infinity e to the power minus lambda t k plus ix by 2 lambda t whole square dk. Let z equals to, if we consider here, root lambda t k plus 1 by x 2 lambda t, dz equals to root lambda t dk. Therefore hx equals to 1 by e to the power minus x square by 4 lambda t 1 by root over 2 pi into dk means 1 by root over 2 lambda t into dz minus infinity to infinity e to the power minus z square dz is equal to even function 2 into x square 4 lambda t 1 by 2 pi lambda t 0 to infinity to the power minus z square dz. Because this is an even function, that's why 2 into 0 to infinity using the even property. And also substitute e to the power x square by 4 lambda t 1 by root over of pi into 2 lambda t. Here 0 to infinity, if we substitute it by some constant variable, another variable u, then we can say e to the power minus u and half of u to the power minus half du. So e to the power minus x square by 4 pi lambda t, 2 will be cancelled, 2 pi lambda t 0 to infinity to the power minus u to the power half minus 1 du. Is equal to e to the power minus x square by 4 lambda t 1 by 2 pi lambda t 0 to infinity. We rewrite this equation once more, this term expression minus u e to the power half minus u du, and that is the property of gamma function, improper integral and gamma function. 2 pi lambda t and gamma half. So gamma half will be root pi, 2 pi lambda t, that will be root pi, root will be cancelled, therefore e to the power minus x square by 4 lambda t by root over of 2 lambda t. Therefore by convolution theorem we get v of xt, that will be f bar of or f inverse of, it will be G bar K and H bar K. That is a convolution of two functions of gx and hx. Therefore, by definition, 1 by root over 2 pi minus infinity to infinity g of alpha h of x minus alpha d alpha 1 by root over of 2 pi minus infinity to infinity, that's g of alpha that will remain same, but h of alpha that will be function of hs, that is e to the power minus x minus alpha whole square by 4 lambda t by root over of 2 lambda t d alpha. We substituting this value, and that will be 1 by 2 root over of pi lambda t minus infinity to infinity g alpha e to the power x minus alpha whole square by 4 lambda t d alpha. So we finally find this result, and how to solve it. We can get this, we can apply this type of method, and it is the applications of Fourier transform method, and basically this is applicable for heat conduction problem in physics and different branches of engineering. And now we end our discussions. If you like this video, like it, share it. Thanks for watching.